Hey guys, today's topic is traveling salesman problem. So in this video I'm going to discuss with you what is this problem and how you will solve this problem using dynamic programming approach. Okay, so let me tell you something about this problem. What is this traveling salesman problem? Let us take one salesman is here and 4 cities we have like Gurgaon, Delhi, Shimla and all, something like this. Here I have taken 4 cities named like A, B, C and D, and let us suppose the home city of the salesman is A. Now what this problem says that the salesman starts from its home city and visit all other cities exactly once and then return back to its home city. Means it will form a cycle, but the condition is, the restriction is, the salesman can visit all the other cities exactly once. Like this, suppose A is the home city of salesman and the salesman starts from A, then he can go to B, then C, then D and then back to A, something like this. Okay, this can be a path. Fine. Next, maybe from A he can go to D, then C, then B and then back to A. Fine. But this is not possible that after A he'll go to D, then C, then B, then again D and then A. Here what is the problem? The node or the vertex D has been traversed, has been visited 2 times, but the restriction in this problem means that salesman can visit the city exactly once. Fine, and he'll have to come back to its home city. So that is the problem of you can say something like you have to find out Hamiltonian cycle where each node has been visited exactly once. Now the thing is, you have to find out the route which is having minimum cost, or you can say distance, or you can say weight. Fine. So here I am going to take example of this graph. Now in this graph, this is the cost, or you can say adjacency matrix for this graph having the weight of each edge. See, from A, this arrow is bidirectional. It means we can go from A to B and then B to A, something like this. So cost of A to A, B to B, C to C and D to D is 0, and cost of A to B is 16, A to B is 16 and B to A is 8, something like this. We have this cost adjacency matrix and we will use this one. Now one method is, that is brute force method. Find out all the possible paths and then you can select the minimum one. Fine. Or you can use dynamic programming to solve this problem. And third method is you can use branch and bound method to solve this problem. In that method, that reduction technique will be used. Okay, probably in next video I will discuss that techniques, and today we will discuss dynamic programming approach. Now first of all, I am not writing the formula first of all directly. I am not writing the formula. I will tell you how to derive that formula. Okay, so I will first of all draw a tree to find out the possible solution of this problem, and we are taking A as a source vertex, or you can say we are taking A as a home city of the salesman. The salesman will start its traveling from this vertex A. Fine. So let us take, I am taking A here. Now from A, where he can go? He can go to B, or he can go to C, or he can go to D. 3 choices he has. Now let us suppose he is going from A to B. Now after B, how many choices he has? From B, he can go to C or D, 2 choices. And from C, same, he can go to B or D. And if suppose he is choosing this path A to D, then from D he can go to either B or C. Now let us suppose we are taking this path A to B, then C, and after that only remaining vertex is D. Then after D, where he can go A, B, D and C. Then after B, where he can go A, C, B, D. And here we can write B. Here you can write C and here you can write B. Fine. So these are the possible paths: A, B, C, D, A, B, D, C, A, C, B, D and something like this. Fine. Now see, I'm going to tell you how to draw that formula, the formula of dynamic programming approach. So suppose I am taking the traversing not from A, let us suppose I am taking the traversing from this level, last level. Okay. Let us suppose the salesman is at this vertex, at D vertex. See, and after visiting all the vertices, what is the condition? He has to go back to its home city. Like after D, he has to go back to A, here also A, here also A, here also A and A. Now, let's take he is at vertex D at this time. Now, where he has to go from D to A. Now, check out the cost of D to A. D to A, we have what? 5. From C to A, we have 4. D to A, same we have what? 5. B to A, what we have? 8. C to A, what we have? 4. And from B to A, what we have? 8. Now let us suppose we are going one level up. Now he is at vertex C. Now after C, where he can go? He can go to D and then A finally. And D to A, the distance or the cost we already have, that is 5. Now you have to find out from C to D. What is the cost? C to D, we have what? 9. So here what will be the cost? 9 plus this one, because ultimately he has to go to A. 9 plus 5, then it would be what? It would be 14. Same with this, from D to C, find out. D to C, we have what? 2 plus C to 4 we already have, that is 4. So this is what? 6. Now this condition here, suppose he is at B to D 16 plus this one 5. What is this? 21. D to B 12 plus here we have 8 and it is what? 20. B to C we have 13 and this is what? 4. Then this is what? Total is 17. From C to B it's 7 plus it's 8 and it would be 15. Now let us suppose the salesman is at node B. Now at B he has two choices. He can go to C or D. We will take minimum of these two, because ultimately we have to find out the minimum distance, okay, or the minimum distance route. Okay. B to C, that is 13 plus here what we have from C to A, we have already calculated, that is what? 14. So 13 plus 14, this would be 27. Okay, I am writing here 27. Now check out this distance also. B to D, what is there? 16 plus this distance is what? 6. 16 plus 6 is what? This would be 22. Okay. Now here what we will take between this 27 and 22, which one is minimum? 22. Then the final distance would be 22. We will take the minimum. Okay. We will take this route, this one. Now here also we have two choices, that salesman has two choices. C to B, find out the distance. C to B 7 plus this distance is was 21 and this is what? 28. Now according to this route, C to D 9 plus this one is 20 and this is what 29. Now out of these two, which one is minimum? 28. So here we will take 28. Now from D to B, 12 plus this one is what? 17. We have already calculated from B to A. So we will take this one, we will take the total 17. And this one is what? This is what? 29. Now this root D to C, 2 plus 15 and this one is what? 17. So out of these two, which one is minimum? 17. Then final we will take what? 17. Now at A, now find out the distance at finally the final distance. We will take what? From A we have three routes, A to B, C or D. Now calculate through this route, A to B. See, A to B distance is 16 plus from B to A we have already found the minimum distance, that is 22. We will take what? 22 and this would be what? 38. Now A to C, that is 11 plus here what is the minimum? 28. Then it would be 39. And A to D, that is 6 plus this one is what? 17. And this would be what? I guess 23. Okay. Now out of these three, which one is minimum? That is 23. So this would be the answer. Okay. The minimum distance route is what? Having the total distance what? 23. If I write the formula, then it would be, see, suppose the function I am taking, that is cost function is G and here I and one variable is X. Here I is what? I is the starting vertex. I am taking I as a starting vertex. Okay. And S is what? It is set of vertices that the salesman will visit exactly once and then come back to its starting vertex. Now see, suppose I starting vertex is A, then S would be what? Set of vertices except this starting vertex. Set of vertices the salesman will visit exactly once, that is B, C and D. This would be the S. Fine. Okay. Now if I write the formula, then that it would be G of I S, then it would be minimum of, see, you can easily derive this formula from this logic. I have already explained the logic, and we are now driving the formula from this logic. Minimum of weight from starting vertex to some other vertex J, and then weight of I and J plus G of, we have taken J, and now here the set would be what? This S minus J, and here J would belong to S. Fine. You can take this one. If I is A, then S would be B, C and D. Fine. Now here what we have done, we have taken weight of I to J. We have now three choices, I to J. Now suppose we are taking J as a, J as B, okay, out of B, C and D. Now cost of A to B we will take, and then cost of J to either this route or this route, means we have taken J already, then we will remove J from the set, that is set minus J. Or if you take C in place of J, I is what? A and J is what? C. Then here A to C we have done, and then we will find out the cost from C to B, this route or this route, and we have taken what? Minimum. That is why we have I have written here what? J, and then J minus B and D, set minus J. Previous set was B, C and D, and after that we have selected C as J, then set would be what? B, C, D minus this C, means set minus J, then that would be B and D, and we will take minimum of these two. J belongs to this S. This is the general formula. Now how we will use this formula and solve this problem? Let us check. Here suppose I is, we are taking starting vertex as A. Then how we will write this one? G of A comma, this is set of vertices other than this A, which this A the salesman has to visit exactly once and then return back to the starting point, that is A. Then this set would be B, C and D, fine, equal to, we have to take minimum of this one. Then how we can write this? Minimum of, you can say weight of I is where, here I is A and J. Now from A we can select either, we can go to either B, C or D. Now suppose I am taking B, A to B plus G of B comma, now which is, the set is what? This S minus J. S is B, C, D and J is what? B. Then the remaining is C and D. Fine. This one here, J is what? B. Now we have three options. You can say W. Now we are taking C. We are selecting C plus cost of C here, and here what we will write? This minus J. J is here C. Then you will write B and D. Okay. And third is, if we are selecting D, then plus this would be G of, sorry, here we will write D and A. Sorry, A we can't write. From B, here you will write D and then B, C, D minus D, that is only B and C are remaining. Now out of these three values we have to take what? Minimum one. We have three choices here. Now we cannot find out the value of this one and this one. Why so? Because this one is recursive call. This function is again using the same function. Now we have to solve this one. Then we can get the answer. Maybe then we can get the answer. So first of all I will take this one. G of B, C and D. We have to solve this now. And this would be what? Apply the same formula, minimum of this and this. Now in this case we have three choices, because here we have, in set we have three vertex. Here we have two choices. We have only C and D. So we can go to either B to C or B to D. Now W of, see here is B now. The starting vertex is now B, because in place of I we have B. Now we will find out the weight B to J. We will select either C or D. Suppose I am taking C plus G of, here what we will write? We have selected C. So here J is what? C. C comma, this one S minus J. S is CD and J is what? C. The remaining is what? D only. Here you will write what? D. And the second option is weight of B. We have selected suppose D plus G of, now at the place here we have what? D, and the remaining is only C. CD minus D. We have selected D only. We have selected D, so the remaining is only C out of this set, S minus J. That would be this one. Now again we have one function, that is G of C and D. Okay. Now we have to solve this one, then we can get the answer. Now I am suppose taking this one, G of C and D. Okay. G of C and D. Now apply the same formula. W, now here I is what? C, then we will take C2. Out of this set we can select any one. Here we have only one, then we will select what? Obviously we will select D plus G of selected vertex is what? D. Here you will write that selected vertex comma this set minus the selected vertex. Set is D and D has been selected, then this would be, you can say, phi. Here you can write this one. Okay. Now we don't have any other option. Minimum of, see here you can write minimum. The formula is minimum. I am not writing minimum. But here we have only one choice. We can select only D. We don't have any other choice. Now we will take this value only. Okay. Minimum क्या होगा उसमें? This is the only value we have. Now what is this value? See, this one is again G of D and phi. But if this something like this, the cost function is something like this, then what does it mean? It means from D to, we cannot go anywhere. So from D we have to go back to the starting point, the starting vertex, and the starting vertex we have taken is what? That is A. Fine. Now here you will write D to A, the distance of D to A, or you can write this as, if we find this one, G of, suppose X is any vertex and phi, then it would be equal to weight of X to I. I is what? Starting vertex. X to I. Now here X is what? D, and weight of D to I. I is what? A. D to A. We will write here D to A. So rather than this we can write here this one, weight of this D to A. Now solve this one. What should be the value? It would be weight of C and D, weight of C to D, that is 9. See, we can solve this one because here we have W only. We don't have any G functions because this is equivalent to this Wx of I, plus D to A, that is 5. Now this would be what? 14. Fine. And next, now we have solved this one. We have value of this one, so we can get the value of this complete. Now weight of B and C, this is B to C, that is 13, plus the value of this complete cost function is what? 14, and what we got is 27. Now see, we have to take minimum of these two because general function में हमने क्या लिखा है? Minimum. I haven't written minimum here, but you have to take care of this thing also. Minimum of these two. Now you have to find out the value of this one. G of D comma set is C. Now this would be weight of starting vertex here is D. D2 we will select any one from the set and we have only one, that is C, so we will select C, plus G of, we have selected C, we will write here C, and then this set minus the selected vertex. Set is C minus C, then it would be 5. Same the value would be, इसको आप क्या बोल सकते हो? We cannot go from C to anywhere, then we will go back to A. Then here you will write cost of C to A, that rule. W, D to C, weight of D to C is what? 2, plus weight of C to A, that is 4, and it would be 6. Okay. See, in this case I have only one choice. We have to take minimum, but in this case we have only this one choice because we have selected C and that we have 5. Set में हमारे पास क्या है? Only one variable, so we can select only one. That is why I am taking this 6. There is no minimum because only one value we have, so we have to take this 6. Okay. Now this one, G, D and C, we have got the value 6. We can put this value here. Here we have weight of B to D, that is 16, plus the value of this is what? 6, and the value would be 22. Now out of these two, which one is minimum? 22. Then we will take 22. Fine. Now we have already derived the value of this function, so we can put this value where? here only. The value of this cost function is what? 22. We have already derived this value. Now find out the value of this one, this complete one, when we have selected B, this root. Now weight of A to B. A to B is what? 16 plus this value is what? That is 22. And the total would be 38. This is not complete till now. We are still having this one and this one. This is the only one root we have explored. Now we will find out the value of this one. Now this is recursive call. Now we have to solve this one first. G of C, B and D. Now you have to take what you can say minimum of which one? Starting weight of, now starting vertex I is what? C. Now select weight of C to any one of these from this set. Suppose I am selecting B first, then plus G of, we have selected B, then we will write B here, then here what we will write? We have selected B already, then the set minus selected vertex, that is BD minus B, and remaining is what? D only. Fine. And next choice what we have is from C we can go to D plus G, D, and here if B is we will minus D from here, then only remaining vertex is what? B. So you have to select minimum of these two values. Now for finding out this value, you have to find out this value first, because this is recursive call. Now let us find out this value, G of B and D. Apply the same formula. See, here we have only one choice, although we can write minimum here. Then weight of B to select any vertex from this set, and only one we have, then we will select D, plus G, selected vertex is D, and remaining vertex from this is, that is S minus J. After we will do the minus of J from this S, this remaining is 5. Now we can select only one, that is D, then there is no other choice. Now this is the only value we have, so that is the minimum also. Now we will find out this value, weight of B to D. Weight of B to D, that is 16, plus we cannot go anywhere, then we have to go back to A. Then here we will write weight of D to A. D to A, that is 5, and it would be 21. Now you can find out value of this one. Here weight of CB, C to B, that is 7, plus this we have already found out here, that is 21, and this would be 28. Now this one is remaining, we have to select minimum of these two. Now for this one, first find out the value of G of D and B using that formula, minimum of weight of D comma B plus G. We have selected this B, then here remaining is 5. Now what we can write, weight of D to B, that is 12, plus weight of B to 5 hai to B to A you have to find out, B to A, that is 8, and here is 20, so we can write 20 here. Now what is this value, weight of C to D, that is 9, plus this, the value of this function is what, 20, and here we have 29. So you have to select minimum of these two. Minimum is what, 28. Now 28 would be selected. Now we can put this value, the value of this one here only, and we can find out this value. Now weight of A to C is 11, plus what is the answer of this function, that is 28. Now this value would be 39. Two values we have got, one is 38 and one is 39. Now with the help of same formula and using the same process, you have to find out the value of this one. Now we have find out the value of this one also, and this would be 23. Now out of 38, 39 and 23, which one is minimum? That is 23. Then we will take this one. So the answer would be 23. The minimum distance route would be 23. When the salesman would start from this vertex A, and then what would be that root? See, we have selected A as a start vertex, then root would be A. Now the minimum, we have selected this one. Now you have to check this one, A to D. First would be A to D. Then when solving this one, D, B, C, we have taken, which one is minimum out of 29 and 17? We have taken what? 17. So you would go to this one. Now after D, what we have selected, that is C. Okay. Now in this one, finally is after C, we can go to B. So the root would be what? 23. So the root would be A to D, then D to C, and then C to B, and then again B to back to A. So that is how this traveling salesman problem would be solved using dynamic programming approach with the help of this formula. And see, in the brute force method, if you apply that brute force method, then the time complexity would be n factorial. You have to find out all the paths, and that would be n factorial. See, in this case, that complexity would be exponential time would be taken. You can say it's like 2 raised to power something like this, 2 raised to power n into, here would be something. Okay. So this is what? Approximately 2 raised to power n exponential. Although it is better than this n factorial, but it is not that better. Okay. So I'll see you in the next video. Till then, bye bye, take care.